So, having seen the 7 systems based on this symmetry, or in other words the cell dimensions and the angles the higher symmetries. So, based on that it can be classified into 32 point groups. But not equally distributed. Now, let us start with the triclinic. We know that A is not equal to B, not equal to C, alpha is equal to not equal to beta, not equal to gamma. So, we need 6 variable. Here no axes are equal and no angles are 90. Now, let us see the point group. Now, let us take the boundary as a circle. Take a boundary as a circle to operate the symmetry. Now, let us divide it. Now, let us imagine there is only one motif, or I will put it as a solid dot. Here this is nothing but the point group 1. That is, when you take into the Eulerian geometry this point, let us say this is my x, this is my y, this is my z axis minus z minus x minus y. So, this point can be represented as x, y, z. So, this implies x, y, z. Further, when you consider two motifs, a dot and a circle. Now, these two can be related by an inversion at the middle. That is to say, you take it in the Eulerian geometry, x minus x, y minus y, z minus z. So, any point here is x, y, z. So, the respective one will be x bar, y bar, z bar. Here in this point with the convention is, when you put a dot, dot represents positive, a open circle represents a negative in z axis. So, that means this is my x, y, z, this represents x bar, y bar, z bar. So, this point group is nothing but P1 bar, sorry, this point group is 1 bar. So, in triclinic system, only 2 point groups are possible, that is 1 and 1 bar. One and 1 bar. Now we have to remember, in crystallography, the point groups represented are different from the spectroscopic point groups. In the molecular symmetries, the symmetry operated within the molecule is considered. Here the two dependent molecules, that is the two independent molecules in the unit cell are related by an inversion symmetry. Now when we go to monoclinic, where A is not equal to B is not equal to C, alpha is equal to gamma is equal to 90, beta not equal to 90. So we know only 4 parameters. Now the point groups. Here already we know that B is the unique axis or symmetry axis. B axis can act, B axis is acting as the two-fold rotation axis, and the AC plane perpendicular to the B axis is acting as the mirror plane. Now with this understanding, first let us draw the projection diagram. Again this is down B axis. Now we know that B axis can act as a two-fold axis. This is a rotation axis. So whatever is here, 180 rotation goes here. That is, now when I take this is x, y, z, this is okay. Let us see in the iron geometry. This is my x, y, y bar, x bar, z bar. So take this point here. When I rotate about the y axis, it comes here. So this is my x, y, say let us say 0, c. This becomes x bar y 0. Or when I say this is my x, y, z, when I rotate about this axis, whichever is up it will go down. So, this becomes x bar y z bar. So, when I say this is my x, this is my z, down y, this is my x, y, z, I am rotating about the y axis, then this becomes x bar y z bar. So, this point group x, y, z, x bar, y, z bar, rotation along the B axis. This point group is called two. That is, now let us take next one. Now, this is my rotation axis, B axis, the symmetry axis, and R AC plane is the mirror plane. Now, take a point here. Now, this is my AC, mirror perpendicular to B gives me a reflection which is below. So, dot is x, y, z, circle is x, y bar, z. Then this is nothing but M, or we will do one thing. Now, we rotate along the B axis and invert this results as is nothing but 2 bar. So, this is equal to M. So, the point group is 2, which is 2 bar, which is equal to M. Now, the third point group is a rotation along the B axis to a mirror perpendicular. Rotation along the B axis operate a mirror, that is AC plane, as the mirror plane it ends up as a dot and a mirror. Dot is positive, circle is. Thank you for your attention. We will continue in the next class the remaining point groups. in the remaining systems. Thank you.